welcome you all to the NPTEL online certification course on Smart Grid Basics to Advanced Technology, and today we will be talking about cyber security and resiliency. As you all know, with the advanced technology those are in place today, especially in power engineering, which accommodates new communication infrastructure and technology. So, with respect to system advancement through technology, they are also prone to cyber threats. So, it is high time that we cannot afford to have a modern power system which can be jeopardized and with improper resiliency, so that the system can never come back to normalcy. So, considering all the facts, today we will talk about challenges related to cyber threats, cyber security, and finally, what would be the strategy so that the system can be more resilient towards cyber threats and cyber challenges. We will start the way to understand what is cyber physical system in the beginning. We will also talk about cyber physical system components. We will also discuss about limitations and benefits of cyber physical system. What are those cyber adversaries with different examples? We will also talk about different classifications related to cyber adversaries. What is cyber security? Definition of cyber resiliency, cyber anomaly detection methods, centralized and decentralized techniques, and finally, the potential research scope for graduate students. Now, when we talk about cyber physical system, the question comes to mind, what exactly cyber physical system is all about. Probably those who are in the field of cyber security research, they may be knowing it, but otherwise it is a new term for most of the engineers today. The integration of the physical and cyber system, please try to understand the integration of physical and cyber system. So, to me you have a physical system which could be your generators, transmission lines, transmission towers, everything which are physical, and then we add on or a top of that there is a cyber system, and those communicate each other to make this physical system more effective. So, there is a cyber layer and there is a physical layer. There is a physical system, there is a physical system and there is a cyber system. So, those two together act as a cyber physical system to me. And the integration of those two physical and cyber system evolves into a new digital technology called cyber physical system. Now, as you could see, these are my physical layers, and then we have actually cyber layers, probably most of the IoT devices, communication, data acquisition, and so and so. So, from this network you can see that it is completely the physical generation, transmission, distribution, and then you have a top layer communication platforms. For an example, let us say you do have PMUs in place in your power systems, and those PMUs actually communicate to your control center through a type of communication, or probably different IoT devices which track all the measuring data from your physical system to the control center. So, the merger of these two in a very advanced way probably can address most of the challenging tasks of this power engineering today. However, they also invite maximum risk involved. How we interact with the physical power system world around us what is the role of cyber physical system in our conventional electric power grids or microgrid structures. So, first of all we need to understand why it is important to have a cyber physical layer embedded with my physical system, and if it is important, then what would be its structure. Now, in general, distribution systems and isolated microgrid structures are evolving with the massive and unprecedented way of development of smart grid technologies, new business models, and the addition of new stakeholders are keep on increasing day by day. Now, if you focus, like most of my physical power system may be a microgrid for an example, and they need to communicate to my control center through different communication networks. Have a close look, we do have generation, we do have actually transmission systems, and then we have residential loads. Now, through the consumers, distribution system, transmission system and generation, which are physical, this is my physical layer, and then we have to track all the information through different communication network, for example, regional data collection system, power plant automation systems, system data collection systems, substation automation system. So, they are the kind of channels through which all the data belongs to physical system will move to next layer, either through dedicated wired networks or utility wired networks, or could be a wireless communication through which all the data they can get into my control center to reach to my energy management system or supervisory control and data acquisition. Now, after that we do carry out lot of processes, and then through AGC, load frequency control, everything being carried out, and then based on the requirement those control signals through this wireless communication can reach to my physical devices. So, what exactly happens? You have a physical system, you collect all the information through a communication network to a different layer of energy management systems, and take appropriate action for your control mechanism, could be automatic generation control or frequency control, and then as per the requirement those physical devices has to operate through a information that has flown through a different communication channel. So, this is how actually both physical and cyber networks actually do interact and talk to each other. Now, in case of a cyber physical component, as you could see that different physical devices they are in place. So, there could be sensors, and there could be communication networking, actuators, and there could be storage and also processing. So, they are all belongs to my cyber physical system. And then you have physical system, those are plants, actuators and sensors, and then you have cyber, those are actually communication networks, protocols, intelligent electronic devices and Internet of Things. Okay? That is how the overall cyber physical system is taken into account. Now, what are those benefits as well as challenges with respect to cyber physical system? Now, if you have a cyber physical system in place, then two-way information and electricity flow is possible. So, two-way flow of information and electricity is possible when the system is actually cyber physical in nature. Efficient, safe and secure operation of the power grid, you can expect that to happen. Flexible, coordinated operation based on global system variables can be achieved. Automation and smart features of the power grid possible. Now, what are the challenges, disadvantages? One could be a serious cyber attack because of having a more technology biased cyber physical system, which is not only physical anymore. So, that means they will invite challenges with cyber threats and failures, and also you may experience communication latency. Then packet dropouts, some data may miss, network jamming and congestion possible, and malicious control effect. So, one side you have a lot of merits having a cyber physical system, and the other way you do have huge challenges. So, you have to see to that how those challenges can be reduced and the benefits can be upgraded. Now, what are those cyber adversaries, examples and classifications? Historically, cyber threat is not a new phenomena across the world. So, I think the war crimes are no more based on physical fights, it is cyber fights in future. So, power grid of Ukraine was hacked in December 2015. The power grid of Ukraine was hacked in December 2015 completely. European network of transmission system operators for electricity hacked in 2020. That means, all your operation strategy is being taken care by somebody else, the third party, through hacking. Russian power grid in 2019, Saudi Aramco petrochemical plant in 2017, 10 power assets Mumbai, Tamil Nadu ports came under REDICO in 2021. So, possibly you could see these are the very common challenges we faced across the globe. Now, cyber adversaries, there are different classifications, and probably one strategy could be FDIA and the other one is DOS, where actually in case of FDIA you use those sensors, communication links and controllers could be the media for data manipulation attacks. And in case of DOS, actually you talk about suspend communications, that could be unidirectional attack or could be bidirectional attacks. Now, we will move to cyber security and resiliency. So, what is cyber security to start with? Cyber security describes a company's ability to protect against and avoid the increasing threat from cybercrime. Okay. So, if you can protect those threats, then you can see you are cyber secured. For example, all devices are running the most up to date firmware, firewalls, VPNs and antivirus malware protection is running and up to date. All software and tools are fixed with the latest patches. Employees at all level of the business, any company, maybe a banking sector or power business sector, are educated on the potential threats. Action needed to defend the organization. So, probably we have to be very, very careful when an organization is attacked, how to protect it nicely. Then what is resiliency? Cyber resiliency is cyber resilience refer to a company's ability not only to protect, but also to mitigate damage to system, processes and reputation, and carry on one system or data have been compromised. So, the importance of resiliency is that you do not simply protect, but even if something has been compromised, you mitigate those damages and come up. Cyber resilience covers adversarial threats such as hackers and other malicious actors, as well as non-adversarial threats, for example, simple human error. For an example, developing offline or online emergency processes to keep essential functions such as customer services, quality assurance, finance and security running, as well as possible until the breach can be fixed. So, to me a system need to be cyber secured, and further it is wonderful if it is resilient towards cyber threats. Now, let us move to cyber anomaly detection approaches. Now, why anomaly detection methods are needed in power systems? Now, detection methods are required for mitigation solutions. Until unless you know the cause of your failure, it is very difficult to repair it. So, detection methods are required for mitigation solutions in order to either continue the normal operation of the system or isolate the compromised part. Either you know detach those affected portion or continue with the normal operation of the system. So, this provides the cyber resiliency to the system against attacks. So, means if you have a system, that means you are not complete failure of the system, probably we can continue working on by compromising a small portion of the network which has been seriously affected. Now, the right side diagram is very interesting, all of you please have a look. So, first of all we will say the top level failure, which is my level 1, all right, and we have level 2, which is physical consequences, level 3, which is the cyber attack, and level 4 is the type of attack or attack techniques. So, whenever there is an attack, so that means you compromise the system, and when you compromise, probably there could be two options available to me. One is malicious demand side response commands. So, means it may instruct you to increase or decrease, for an example, generation of a plant, though it is not expected. Are you clear? Assume that the load is keep on increasing and you are receiving an instruction to reduce your generation. What does it mean? It is malicious, and it is a kind of anomaly which is not expected to happen. The malicious commands to exciter and prime mover reference setting through SCADA system. So, you can do that by manipulating those reference signals, and by doing so there could be a sudden drop of load, which is very unfortunate, or hence leading to frequency imbalance due to drop in power generation. So, you can play both with the load side as well as generation side, and that mismatch will create huge frequency variation. And finally, you will experience the performance of the power system affected, means slowly one after other units and section of the power system become black. So, you will experience blackout scenario in a power system through cyber attacks. So, this is your attack techniques, then cyber attack, then physical consequences, and finally the system fails, top level failures. Now, how do you detect those anomaly? So, cyber anomaly detection approaches. So, there are first centralized architecture, and you can also have a distributed architecture to understand those. So, if you understand the centralized architecture, the methods, which is knowledge based and data driven. However, in case of distributed architecture, methods that are robust not only against disturbances and measurement noises, but also against incomplete measurements. And you could see the left hand side diagram, which represent your centralized communication architecture, where you can do information sharing. This may centralized network, and everyone actually communicate to this centralized setting. However, in case of distribution communication architecture, which is peer to peer information sharing, and as you could see that this is my operation center, and then you have similar sections, this is 1, this is 2, this is 3, and this is 4, and they are distributed. So, they can carry out their own strategy and inform to the control center. So, probably there are two kind of arrangement, one is centralized as well as decentralized mechanism that can be adapted for cyber anomaly detection, and most of the centralized detection approaches are either through state estimation, CHI square method, residual based method, binary hypothesis, and model free based ML and stats. So, these are the different concepts, and probably you can do a detailed study. I mean, this is a huge area to explore. So, I suggest all my student friends to spend bit of time and try to understand more about cyber security and threats. This is a very hot topic for all of us to explore. Now, when you go to distributed detection approaches, the first one is centralized methods after approximation, singular value decomposition, fault detection and identification, observer based approach. So, either you can go for a centralized approach or distributed approach, and these are different algorithms made available to you for your analysis. Now, what are those potential research directions that we all can explore? So, the areas are distributed attack detection, and this also could be a concurrent attack detection, scalable attack detection, detection of other attacks. So, the first one, which is distributed attack detection, and new techniques for distributed systems, and concurrent attack detection, where simultaneous attacks on multiple communication links need to be identified, very challenging. Scalable attack detection, extending the detection algorithm to a large size problem. Okay, you have done something for a, let us say, n number of system, now you are expanding to 1000 n, 2000 n system. Now, detection of other attacks, one technique could identify different categories of attacks in any system. And probably, I mean, this is a huge area, as I told you. So, these are the references being used to prepare this study material. So, please go through this and also try to explore other articles, and most of the materials are being taken from this reference 4, and probably other references also helped us a lot. So, you can read Ukraine Power Grid hack Wikipedia to understand more about those, and power grids under attack. So, these 5 and 6 references are also equally important. So, with this we come to an end with basic understanding of cyber security and cyber resilience system, and this is an important area, and I am very confident you have enjoyed it, and thanks for patient listening to me. Thank you.